Find the average value of the function over the given interval and all values of c in the interval for which the function equals its average value. F of x equals f 4x cubed plus 1 on the interval -1, 1.
Okay, for the average value, all we need to do is integrate this and divide it by the number in between. And I know that is pretty much common sense because you guys all know how to find the average of anything. But in case you might have forgotten, here's a formula. It is 1 over b minus a of the integration from lower to upper bound of the function. So we have, in this case, we are going from -1 to 1, so that's my a and b. And b minus a, in that case, it's going to give us, oh, I should write out f of c is equal to 1 over 1 plus the 1, right? 1 minus a negative if you want to. In my lower -1, upper is 1. The function given is 4x cubed plus the 1 dx. And it's calculator active. So let's see if y'all remember the button. When I go to math, which one is going to allow us to integrate? 9. But then what if I do F9, it's going to give me that skeleton model. For me to put the number in front, I should go ahead and do alpha y equals first, 1 over 2. And then do math 9. I guess you can divide it by 2 at the very end too. But I want to put them all at once. Then we have 4x to the power of 3 plus the 1 of dx. So make sure your calculator looks exactly what the paper says. Is everyone good with that? So when I press enter, what do I get? 1. So we know in this case, f of c is equal to 1. And I want to find when the average value is equal to, what was the other? The function. So it says it is equal to the function given. So our function in this case is 4c cubed plus the 1. You can leave it as x if you want. Is equal to 1. And I know 4c cubed is equal to 0. And no matter what I do with the 0, what is my c? 0. Did someone say 1? Oh no. All right, let's move on to number 17. Is that right? We're going to pretend we didn't hear that. All right, on number 17. Okay, Addison, go ahead and read 17 in part A.
The graph of the function f is shown to the right. Let g be the function given by g of x equals the integral from 0 to x f of t from dt. Find g1, g of 1, g prime of 1, and g double prime of 1.
All right, so we know g of x is the integration of the function. So let's put on here g is the integration of the function. And every time we integrate, that as the area under the curve. And it could be a line, of course. So if I integrate the g, that's going to give me g prime. Not integrate, if I derive. And deriving the integration, they cancel each other out, so we have f. So that means g double prime is our f prime. So the f is a graph given, so that's our y value. F prime must be the slope at that specific point. So given that, let's go ahead and answer our 3 pieces. The first one says g of 1. And we know our formula is given, so let's go ahead and integrate from 0 to 1 of f of t dt. So let's see what that says. From 0 to 1 is this figure right here. What shape is this? Triangle. And let me kind of make it a little bit more evident. If I want to find the area of this triangle, it is half times what and what? Base times height. So we have half. My base is 1. What is our height? 3. And that's going to give us 3 over 2. And then it says find g prime of 1. So g prime of 1 is really in the end f of 1, meaning what is a y value when x equals 1? So when x equals 1, what is our y value right here? 0. And then the third piece says, what is g double prime of 1? Which in the end, it's going to ask us, what is f single prime of 1? So what is a derivative of, or what is a derivative when x equals 1? So when x equals 1, what is our slope here? If you do rise over run? -3. So part A is done. Colin, let's read part B.
For what values of f in the open interval from -2 to 2, the graph of g increases?
So graph of g. So I'm going to go on to f, integral of the f. If it is increasing, what do I know about the f? It is positive. So I'm going to go ahead and check and see where I have it positive. Above here is positive, below is negative, above positive, below is negative. So at what intervals is it positive? -1 to 1. And that is because the g prime, which is representing the graph of the f, is positive. If on your test, if you just write g prime as positive, f is positive, one or the other, it's fine. But I want to make sure you guys have options. And then my last piece, Maddie, let's read.
For what values of x in the open interval -2 to 2 is the graph of g concave down?
Okay, the graph of g is our integral of the f. That's concave up, concave down. Concave down means it is decreasing. So we know the graph is decreasing all on this side. Is that true? So it is decreasing from what interval? 0 to 2. And that is because the g prime, which is our function, is decreasing.